this kind of mass production. That is my my general comment. Yeah. Okay, so I think we should try to invite the Dr. Yang to let me see. I don't know if Dr. Yang, can you share your screen now?
Yes. A moment. Can you see the screen?
Yeah. Yes. Sure. Yeah.
Shall I start now, or
yes,
just wait
sure.
for some
Please
other
go ahead.
student?
Yeah.
Okay. Okay. First of all, I'd like to give thanks, truly thanks for the next introduction about myself from Professor Lee, and I'm so glad to be here to give the lecture regarding the Research Center Hong Kong Center for the Construction Robotics, and also about our commercializing products. And in this slides, I'd like to give you a brief overview about what the construction will be like in the future. And at the beginning, I'd like to introduce you the Hong Kong. In Hong Kong, we have a lot of different centers funded by the Hong Kong government to do a lot of international or local research for the advanced technologies. And the aim is to bring the research in the universities, like in the leading institutions or some other countries from locally and internationally to commercialization to products. And then we can make profits and benefits for the society and the human beings. And HKCRC is one of the centers funded by the government. And for more details, this center is aimed at doing the research for like world-class or international technology regarding construction. And we want to do bring the robotic technologies to the construction site to provide the end-to-end smart solution to improve the efficiency, to improve the safety of the construction site. And this center established by the Hong Kong UST and University of Berkeley, University of California, Berkeley. So these two universities have cooperated deeply for the robotic technology and also build up a lot of different products. And as Professor Lee has mentioned, we have already developed this center for 5 years. So we build up different corporations. We have a lot of different cooperators, like the partners from the garments in industry, and also from the garments, we can build up a lot of like the procedure proposals or even standards of the construction site, and also give the solutions to the government and companies. So this center is somehow a combination from the research, academic domain, and also the government as well as the company industry together to provide the solutions for the society. And first of all, I also need to give you the details about the research group of the center. This center is directed by the Professor Zhexiang Li, which is a professor in HKUST. And he's not only the director of of our center, he has also established in different types of incubation center, and he's also a co-founder of the DJI. So he has brought a lot of different brilliant ideas of different research domains to the industry, and also build up a lot of amazing products in the society. And apart from him, we also have a lot of other professors from HKUST, UC Berkeley, or other universities internationally and locally. So this center has already obtained over 300 million Hong Kong dollars over the past 5 years. And we have conducted different research and also bring different kind of commercialization products. And we are now entering the new 5-year phase. So we are going to build up the different new research topics or different new products and different proposals in the next 5 years. So in the last 5 years, we follow the pipeline for commercialization, which is 4 steps. The first is to do the investigation and survey about the marketing, about the demands of the industry would like to see, what the worker users or what the companies want us to have. And according to their demands, we can build up some research proposals or like bring some ideas about what we are going to do. And according to this proposal, we are going to build up some products and deliver some solutions, and which is the base of building up some startups. And then we finish the commercialization. Normally, after the commercialization, we can spin off different companies, and which is actually startups from our research center. And in the last 5 years, we have spent different companies for like scanning sensors or some other transportation robots to the society to they can run their own company and economy themselves. And apart from this research center, we have also built up some other system for the incubation to bring different brilliant ideas to the society, to the industry. Like in Hong Kong, we have different places, not only in Hong Kong, also in Guangdong province. And we also built up some other centers or incubation center for the western or eastern part of the Chinese mainland. So this is like connect between different parts of China to bring the commercialization, to bring the research ideas to the industry. And I suppose everyone that joins this kind of research center can share ideas with each other, can learn from each other, and can also do brilliant research and do the commercialization together. So this is the whole connection for different research centers directed by the Professor Li. And in next slides, I would like to give you the details about what our HKCRC is doing for the construction robotics. And we, in the new 5-year phase, we are going to focus on 3 different research topics. One is the AI design, which is similar to the ChatGPT, but we bring this idea to construction robotics. And for the ChatGPT, normally we ask some questions for the AI tools. And so we also have a lot of other different AI tools to do the image generation or to ask questions to know what we want to know. And what we want to do now is to do the design by AI tools, that if you give a prompt or give some demand or requirements about what you want to do for the layout of your room, of your home, or the building, the AI design tool can help you to design the whole layout of the room. And it is automatic. And if you don't feel satisfied by the design, you can also change your demands and modify the design. So it can save a lot of time for the designers of the construction site. And the second part, we focus on the single task robots. And what we want to do is to finish a kind of repetitive task in the construction site, to replace it, to help humans to reduce their pain, reduce their time to do this kind of single task. Such as we can do the rebar tying, we can do the transportation of some construction materials. And in the third part, we would like to focus on some large scale machineries. And for the single task robot, we only focus on a really small robot, but for the larger scale, we focus on quite heavy and a little bit dangerous and large machineries like the tower crane, excavator. And we do not only focus on the automation of these machines, we also need to do the assessment of the risk, like to monitor the safety of the human workers or the safety of the machines. So as I have mentioned, we would focus our research, our commercialization robot on three important research topics and also three important aspects: the efficiency, the safety, and the automation. So according to what we are going to focus, we also need to include a lot of different technologies. For the AI design, we need to bring the generative AI methods to the design of this task. And for the some other robots, we need to also bring some intelligent methods like object detection, digital twin, or some scanning method in 3D to the robots. And of course, the most important is the robotic technologies like the manipulation technology, how to do the object picking and placing, how to do the transportation, and how to do the autonomous driving. And apart from that, we also want to consider some automated manufacturing process in the factory. Because in current time, the construction does not only do the construction on the site, we also consider do the construction in a factory, which is called the fabricated factory. Fabricated manufacturing for like the rooms. We build up a kind of room in the factory and then transport it to the construction site. And the last important aspect is the energy and the materials. So, which is actually, I would say, this is also quite important because we don't want only to improve the efficiency of the construction site. We also need to make the whole process environmentally friendly, also sustainably, to make it better for our human quality life. So after introducing the brief overview of the research center is going to do, I would give you the details of each robot, each solution we have provided for the society and the construction site. The first is the AI design tool we have developed, which is actually designed. This method is developed for the layout of interior. Like a user can input some prompts or input some demands or requirements about their room or about their layout. This tool can automatically place where the bed is, where the toilet is, and where the other furniture will be. And if the user feel unsatisfied about the layout, it can also change their demands and requirements. And then the AI tool can automatically calculate the size of the furniture and also the size of the room to arrange all of the layout automatically. So another fancy point is this layout can will not only consider the arrangement, also consider the size, the diameter of the furniture to tell you whether you can put so much furniture in the room or not. So it can help a lot for the AI architect to do their design, to do the planning of the construction, to do the planning of, as I have mentioned, we want to do the construction in a factory as a fabricated manufacturing process, which is called modular integrated construction, MIC. So in constructing this kind of MIC, this method, this model will be really helpful, I would say, in the future. And the second, I would introduce you the AI-based inspection for the construction, the building, which is based on a drone. It flies around the building and detect where the defects will be and where is broken, where we need to do the reparation. So normally, this task is done manually by the human beings, which is a little bit time consuming, also really tiring, because human need to work around the building and also need to inspect by eyes, which is not that accurate. And especially in Hong Kong, it's really hot outside, so we cannot work a long time outside. So using this kind of drone, we can just control or remotely to fly around the building and detect where to repair and how to repair, and also to like check the quality of the building. So this is a method to improve the efficiency of inspection, also reduce the human pains. And the third one will be also about the working condition of human workers, because sometimes in a construction site, it is really complex and dangerous. So we cannot do all the work manually. So we want to use some devices, sensors to replace the dangerous or painful work of a human. And this is a kind of sensor to detect the structural safety. So in the construction side, we do not only focus on the safety of the human workers, we also need to focus on the safety of the devices, of the structures of the buildings. So we need to monitor from time to time or even long term, but we cannot do it manually or by human. So such kind of sensors or methods can help us to do the measurement, to like to see whether it will have some broken parts, or whether we need to find some place to repair. So this is also a method to improve the efficiency of the work. And apart from the AI design or some other sensor measurement solutions, we also provide some single task robots, as the video shown here. The first one is kind of a mobile robot developed to build up a 3D model of the building. So this robot can move automatically around the room. It's similar to the cleaning robot in our room. So it's automatically working around the whole room and using the LiDAR or laser to detect, to build up a kind of 3D digital model for the whole building, which can be used for the further later on analysis, like to do the arrangement and to do some reparation or to do some construction in the future. And so in the second part is about the software-based solution, which is designed to do the arrangement of the construction procedure. So, because in the construction site, it is so complex. We have so many places to construct. We have so many tasks to finish. And the project leader cannot monitor the whole procedure for each detail of the construction. So we need to build up a kind of software or system or platform to provide the detailed procedure of the whole construction to him. And then he can know what is going on the construction site, and he can make his own decision properly. And the third is about the transportation robot, as I have mentioned. And in the construction site, we have a lot of material that are really heavy, which is difficult for humans to move. So this robot seems quite simple, but it is really helpful because it can move those material from one side to another, and it can also reduce the injuries of the human workers, and it reduce the pain, reduce the energy needed for from the human workers. And the final one is to do the grinding floor, which is also quite important for the current construction site, because normally after the construction, the floor is not even, it has a lot of defects. So we need to make it even to do the grinding. And normally it is done manually, which is really time consuming. And also the environment is not good for the human body. So we design this kind of robot to do this task automatically. And the human does not need to be there for a long term. So the robot can automatically do this task and to replace this dangerous work, and the human can just release from this kind of dirty work. So apart from this kind of robots, I would like to also introduce our famous robot, which is a rebar tying robot. And in the construction site, the rebar is so common, and we need to build rebars for everywhere. So normally we need to do the combination of two rebars for, like, we have a lot different nodes in the construction site of the rebars, and we need to combine them together. And after combining, after tying the rebar, we can put the concrete and the solid inside of the rebars to build this construction. So this is an important procedure by combining two rebars together. And this is normally done manually in the world, in different countries. And we have tested this robot in different countries, like in Dubai, in Hong Kong, in the Chinese mainland, and also in Singapore. And we can see that this robot can improve the efficiency of tying rebar, and it can also reduce a great amount of work of rebar tying work. So it is quite helpful, and it is also commonly used in the construction site. And apart from those different kinds of single tasks, we also have some other like help human to provide energy, because even some work is not that painful, but if given that we have conducted this work for a long time, we feel really tired, we cannot continue work for so long time. So the robot, the first one robot, or the first one device is designed to provide the energy for the human elbow, and the human does not need a really great amount of energy to do the work. So the human can do more time work, and it can have feel less painful or less tired after doing this work. And the next three robots are designed to do the layout. And because in the construction site, there are so many lines, so many curves to draw, and this is also done manually by humans, but it's quite repetitive work, and it can be replaced by the robots. So we design such kind of robots to draw the lines, to draw the layouts on the site, to help humans to get their next stage work. So these different single task robots are designed to replace a single task for the humans, but our focus is not to replace human. We want to replace the work, but help human to help reduce or release the pain of the human workers, and also help the human workers to improve their efficiency. So no matter what the commercialization products are designed, well, what we are going to do in the future is not to replace human. We want to just replace the work. And according to the robots I have mentioned, we can build up a kind of smart factory, such as we can do the rebar tying in the factory. We can do the measurement by some sensors and transportation of the materials. And that means in the future, the factory does not need a lot of work from the human workers. It just needs robots to do the work and around, and we can just release the human to do some more intelligent and more useful work in the future. And in current time, it has already been achieved somehow, such as this kind of large machine can transport a lot of different materials from one side to another side. Some other companies also use some robotic arms to move these kind of materials. But those solutions are designed programmably. I mean, those positions of the materials are fixed, so they cannot change the positions of the cargoes of the construction materials. So in the future, we are going to bring more AI technologies to these kind of devices to make it more intelligent. So if we change the material, if we do different type of work, robot, the system can also handle that situation. So in the future, we are going to make it a non-standard robotic arm or devices to the transportation, to the picking and placing. And this is also a video I want to show you about the MIC factory, as I have mentioned, because in the current time, the most famous construction style is to construct the integrated construction part, like a room or small part of a building inside of the factory. And then after building different rooms, like in here, we can transport this room to the construction site, and then like a Lego, we can just stack them together to build up a high building in a really short time. So as I have known that in Hong Kong, we have already conducted this procedure already. So it improved the efficiency a lot, and also can help to build more better quality of the construction in the construction site. So in the future, we are going to bring a lot of different technologies to this procedure, namely MIC procedure. So like the inspection of the diameter, inspection of the quality, and how to do manipulation of placing of construction by the robotic arms automatically. And the third part of the focus of our research center is a large-scale machinery on the real construction site. One of the most important parts is the smart tower crane. What we want to do is to achieve a fully automated tower crane, and we have established a kind of a laboratory tower crane to test or verify our algorithms to see whether it works. And the final goal is to achieve some remote control of the tower crane, as well as the fully automatic transportation of a material on the construction by the tower crane. So this system can automatically detect where is the starting point of the transportation, where is the end point. And it can also avoid the obstacles during transportation from one place to another place. So in the future, I would say this technology can help the transportation task in the construction site a lot, and the drivers do not need to climb to the tower crane, which is actually really dangerous, and people need to work in a really high place, so which is a little bit dangerous. And in Hong Kong, every year there is some tower cranes that collapse and fall down, and several tower crane drivers just died from these accidents. So I suppose this kind of technology can improve this kind of situation and can reduce the injuries, or can reduce the number of the accidents in the future. And the second I want to mention again is that we have built up a second version of the rebar tying robot. And the first version is quite simple, but in the second one, we can improve the efficiency of the rebar tying. We can also transfer the robot from one line to another line. So after finish one line tying, we do not need to move the robot. The robot can automatically move to another line to conduct to repeat the whole procedure. And the second important part is this robot can also avoid the obstacles. So if some humans are standing in front of the robot, it can automatically detect where the human is and then stop the robot to avoid some damages of the human bodies. So this kind of second version of the robot has been tested in different construction sites, and it is also a commercialization product for our center. And we have already built up a lot of these kind of robots and sell them or rent them. And this business has been run in a separate companies spin from our research center. And according to all of the different robots I have mentioned in the last several slides, I suppose in the future, the construction will include different solutions and include different intelligent methods to make the future construction more efficiency, more safe, and more more intelligent. And the human does not need to be there all the time. It can also do a lot of work automatically, and also reduce the pain, reduce the injuries happening in the construction site. So our research center is going to continue to provide different solutions apart from the products I have mentioned. We are going to do like excavator or some trucks automatically to do the transportation in a cave, or some other smart rulers or sensors or scanning for the 3D models of the buildings. And there's one product I would like to mention here is also a product of spin from our research center. This device can do the scanning in 3D, which is colored, and it is quite nice and fancy because it is already used in some current famous games or current famous construction site. So, and the second one is the smart ruler, which can measure the vertical of the wall, whether the wall is even or not, to measure the quality of the wall. So it's quite simple for the easy to use for the users, and we are now beginning to sell this product and to run as a company. So this is also following our rules in the research center, because we are not only doing the construction research, we are also focused on the commercialization. So this is quite important for our research center, and we also provide a lot of different solutions. And in the future, we also going to provide more. And apart from this robotic robots or products, I would like to also mention some other like workshops or summer school we are going to deliver, because we do not only do the products ourselves. We also want to train the students, to train the external users to do their own products, like to bring the research topics or research ideas to commercialize the products, which is actually an incubation system. So we have organized different workshops and summer schools. These are the images from the last several years. And if you have any ideas, or if you have something you want to do or you want to achieve, you can also just join this club, join this summer school, or join us to bring your idea to some products to build up your own startups in the future. And these are the photos of the summer school we have organized. And people or students come to us and have fun and build up their products, and also enjoy the startup procedures. So I think it's quite fine to build up startup, and to do research, to do the commercialization. So this is other slides I have shown together today. So if you have any questions, you can just feel free to ask. Anyone have some questions?
I would like to thank Dr. Yang's the kind of presentation for this Hong Kong CRC. It's clear. I mentioned you look at the presentation so that we have been working on this international research center for about almost 5 years. So that at this moment, I think we have in a much more mature stage. So that of course some of you, if you're still undergrad student, you're welcome. At least I think today was give you this kind of brief introduction, let you understand, right? So that from my point of view, as I mentioned, in those conventional building engineering, somehow still they don't use advanced technology, right? So that especially in Hong Kong, typical this construction worker is like 50 years old, right? So that how can we using more automation, AI, and robotics to solve the real problem on the industry? At this moment, I would say still it's a big issue. Yeah. Okay, I don't know if student has any question or comment. Any question or comment about this kind of unique, this kind of introduction about this kind of robotics, automation, and also those portable sensor for this kind of for this in the construction. So any question or comment? Now what?
Except for the unemployment, it will cost.
What's the question?
No, it's not a question, but I see if we learn more of these technologies, there will be less need for actual laborers working at the construction site.
At this moment, I think this student asked a good question. If this kind of robot will take over all this kind of job,
it will definitely take over some of the jobs. And working in harsh environment, but they have
I see. Okay, I think let's ask the Dr. Yang to give the comment or answer to this student. I understand why all the young students now face some problem. Right? If all the AI or robot so good, so that are you going to your job will be faced by all the robots. This is I think usually I would say this is still some concern from student. So Dr. Yang, do you any comment or question, comment to answer?
Actually, I have mentioned in between the different slides, I have mentioned that we are not going to replace humans. We are only going to replace work. So the human workers do not need to like lose their job. They just need to learn how to use the robots, how to work together with the robots instead of from our researchers' point of view, we do not want to replace human workers, but maybe the industry, the company want to do the replacement of the human workers. But the initial idea is not to replace, to not just let the human lose their jobs.
But I will try to make a comment about this student question. See, from my point of view, you know that it really depends on industry. In some industry, for the automation industry, autonomous make a car, and then it's a lot more robot in the factory to build a car. I think I show you about Xiaomi, the kind of electric car. But in the construction industry, they're still using old technology. You know, industrial 1.0, 2.0, 3.0, 4. So that from my point of view, most likely we this kind of automation or robotics for construction industry most likely is try to upgrade the kind of old technology, be more, but I don't think reach the level of those automation or robotic system in like the this car industry, automotive industry actually is a lot more thing to use, but somehow this kind of construction industry still left behind too much. That's what I witnessed when we Professor Xiang Li asked us to start to write a proposal like more than 5 years ago. I find actually it's compared with the other industry, this kind of construction industry, it's always using some very old technology. Huh?
Do you think the tools your project implement is good enough, or have a smooth learning curve for a normal construction worker that have no background in these kind of things, or in maybe, yeah.
Okay, so the student also asked another question, so that if we make a robot for this kind of a construction industry, so that if typical worker, right, maybe they didn't get the very high university education or something, so that if they can easily use this kind of a robot for I say.
If the robot goes wrong, will they have the ability to fix it or solve it, or what? Or have any other procedure if they don't have the professional knowledge themselves?
Well, I think you are good to ask a good question. So Dr. Yang, what's the comment? So that typical this kind of a robot for construction industry is that, because that's related to UI, right? User interface. Just like if you try to think about your user, right? And then you have to design much better user interface, just like Apple, the iPhone, so that it be more easily used by everyone. Yes, I would say that's also require additional engineering from my point of view. Yeah. Dr. Yang, do you have any comment or answer to this student's question? Huh?
This, you mean we need to do the robot can be used for everyone, or make it professional?
For those existing construction worker, if they don't have a lot more knowledge and skill, it's easy for them to really try to use this kind of robot for real, this kind of manufacturing of the building.
Normally, we need to provide some training for the users after installation of the robots. So normally, the robots cannot be used directly by the workers. They need to do some training, or they need to learn how to use a robot. That is not that difficult, just easy to be used.
Like this is the point you will see that there are more skills are involved being in that position. Like yes, position require knowledge of like.
Can you come? It's easier for because there's some. Can you just talk to Dr. Yang?
Okay. Yeah. Like I understand that like currently there are when you are using a crane construction site, you need to have a license and something like that. Like you are spreading, like your design, I think, is spreading this requirement on training to be more popular or in construction workers, which when I think about it, you are actually increasing the difficulty to become a construction worker. Like not all of them, but some of them.
You mean how to compare the work is efficient? The efficiency is improved, or?
Sorry.
So
I think the student asked question to see probably if we make more robot or automation system for construction industry, probably for my probably they need to get additional education.
Yeah.
I see continuing education, make sure they have upgrade a little bit more skill to use this kind of machine, using the new product, robot to I can see you yeah.
And you need to understand that like some kind of jobs like this that require low amount of training or expert knowledge is still required in the society for its purpose. Maybe just as simple as decreasing the unemployment rate. Okay, when implementing these kind of machines, yes, it will have a first drop in labor in working labor because of the efficiency increase or have it partly fulfilled by the machines. Then the problem of you have to retrain the workers to know how to use these machines, which makes more gap between expert construction worker from a person that may just start to be a construction worker.
Actually, during the development of the robots, we need to make it easy to use. Like for the iPhones or for the smartphones, at the beginning, no one doesn't know how to use it, but we need to learn because the time changes, the world is changing. We cannot only just stay stable and do not move forward and do not learn any new stuff. But as a researcher or developer, we want to make it easy to use, but we still need to learn some basic usage or some basic skills to use the robots.
So I told you, from my understanding about our PG student or RA who work on this kind of real prototype, they have to go to the construction site to stay there to understand their typical worker, how they do the thing, and then gradually develop. This is something you have to have some good interaction with your customer.
Obviously.
And then to develop kind of a robot or automation system. So typically we require our the kind of RA or our P student, they have to go to construction site, really stay so sufficient a period of time so they can really understand the real problem of those construction workers, and then gradually develop the kind of prototype and then get feedback. So all this kind of design and prototyping, it usually takes iteration to improve. So that I just tell you that I think you made a good question, thing, but on the other hand, actually at least from what we have a series of this kind of project, most likely they really go to construction site to really work with those workers. So that this kind of interaction is important. If you only stay in a lab, you don't interact with your customer, then your design or prototype may never work. May never work. Huh? Okay. I think this is a very good question. So I don't know if we have some additional question from the other student. Huh? Anyway, I would say it's quite interesting and quite important for our student to first understand about this kind of interesting way to look at this kind of research, right? Research, R&D, and then most likely they really do some practical engineering and then try to solve the real problem. Okay, of course, I still remember like I take out those kind of 30 or 40 years construction robots in Japan, South Korea, and also look at some additional international kind of experience, right? How they spend 30 or 40 years on this kind of construction robot, doing that, so that the different country region, they have different way to work on this part. Japan has been doing excellent this kind of robotics R&D and product, so that they have their own way to work on this kind of construction robot. Of course, the problem of what's problem of those robots, construction robot developed in Japan, that's also quite important thing for everybody to understand. They have Japan is really top, now world top this kind of leading country to make many kind of industrial robot, especially for those manufacturing in the industry, in the car industry or something. There's several big company, but unfortunately, in those kinds of construction robot, now in Japan, they didn't reach some sufficient the kind of demand. So it's much more challenging to turn the kind of construction robot in Japan into the real product. Okay, I told you like 5 years ago, I dig out those kind of Japanese, the kind of research paper and PowerPoint presentation of big company, I do really understand this kind of international experience on this kind of in the past 30 or 40 years. Yeah. Okay, so in any especially I do remember that's another important thing. Right? I have my own way to study this kind of Japanese research paper and also those big companies R&D report and PowerPoint presentation so that we understand, right? So when we do research, we have to understand all the existing research and prototype internationally. Yeah. Okay, so any other question, comment? Okay, again, this from my point of view, the reason why we can get this kind of 300 million Hong Kong dollar from Hong Kong for the phase 1 is really we try to target for the local shortage of construction worker, right? And of course, locally, the Hong Kong government also have some problem, right? They don't allow those kind of construction work in mainland China to come to Hong Kong. So that's why so there's a local problem. So that's why we get this kind of funding to solve our local industry problem. Okay, but it's actually across border now. Still, in some young people, they don't want to work as construction workers. So actually, if you look at those kind of Greater Bay Area, they also have some shortage of this kind of worker now. Yeah. So that this is something. So that's why if you look at Dr. Yang presentation, you see actually we also not only have a collaborate with local company in Hong Kong, also in China. Of course, we also gradually also going to additional other country and regions. So like in Saudi Arabia, right? So there's a big construction, this kind of project on in the kind of Middle East, right? So that we gradually also want to see if our this kind of research experience product and can be useful internationally. Okay. Okay. I don't know if any question or comment. Okay. I think at least we see we have some student who make a good question. That's is important thing, right? So that if you only try to listen to our this kind of presentation by our speaker, Dr. Yang, without try to ask question, and then somehow I thought this is something you are not in this more active mode to learn something new. Yeah. Okay. So any other question? If not, probably I think that's it for today's lecture. So that I think let's try to give this kind of warm approach to Dr. Yang, who really spent time to give this kind of brief, the kind of introduction about HKCRC. So that again, I think this is quite interesting. And of course, if you're interested, so that Dr. Yang said that we have some special like a summer camp, right? I think still open, right? Summer camp, the kind of training program. So that I think I do witness that we with the kind of training program. So that by the kind of Professor Xiang Li's the kind of 10, 20-year experience. So that before and after the kind of training program, our student really has a big improvement about how to do market research, how to work on the kind of work on the R&D, to make a good prototype. All this kind of thing is somehow is required this kind of good, the kind of training. So that is something I do see. We have a series of this kind of students who got the kind of training, so that they really acquire a lot more good hands-on the kind of engineering skill. Hands-on means you sit in the class and then if you really don't try to use your hand and then try to get your hand dirty to work on making prototype, and then if you don't go into the real